Hi everyone, in this video we are going to discuss another coding problem. The problem is we have to find the second largest element in the given array. If you are sitting for any coding interview, if interviewer asked you any coding problem, so you have to start your solution by brute force approach. And then you have to optimize your solution further. You reach better solution, and then you have to most optimized approach is known as optimal solution. Okay, we are starting with a brute force approach, and then we have moved to better approach, and then we finally move on our most optimized approach, which is known as optimal solution of this particular question. Let's start. This is the brute force approach. Here array is 1, 2, 4, 7, 7, 5. We have to, first of all, what is the first thought in our mind? We have sorting this element. Firstly, we have sorting this element in ascending order. We get 1, 2, 4, 5, 7, 7. And then we have to report second largest element. So second largest element, what is second largest element? The second largest element is the element which is smaller than the largest element but also greater than the other elements. What I am here to trying to say, what is the second largest element? The element which is smaller than the largest element but greater than the other elements. Here 5 is second largest element which is smaller than the largest element. Largest element is 7. This is our largest element, and 5 is our second largest element. Okay, here 7 is our largest element and 5 is our second largest element. We have to find the second largest element. Okay, so the second largest element is 5, which is lesser than the largest element but greater than the other elements. 5 is greater than 1, 5 is greater than 2, 4 is lesser than 5. So second largest element is the element which is greater than the other elements except the largest element. Okay, so what is the code for this? We have to traverse an array for int I is equal to n minus 1, n minus 2, sorry, and I is always greater than and equal to 0 and I minus minus. Okay, and before iterating this loop, this array, we have declare largest element. How we find our largest element? After sorting ARR of n minus 1, this index is n minus 1, this index is n minus 2, and this index is n minus 3. Largest element is always the last index of the sorted array. How we sort any array? Simply arrays dot sort, and here the name of array. This is the one line code for sorting any array in Java. And then we have a compare if ARR of I is not equal to largest. If not, then second largest is ARR of I. First of all, we have sort this array, and then what is the largest element in this sorted array? The largest element in any sorted array is always present at n minus 1th index. Okay, so we declare largest is equal to array ARR of n minus 1. Okay, because the largest element is always present in a sorted array at n minus 1th index of that particular array, and we have traverse this particular array by n minus 2, by starting of n minus 2th index. Why we are traversing this particular array from n minus 2? Because sometime if ARR is something like this, ARR is equal to 1 2 4 3. So after sorting this element, after sorting, this ARR becomes 1 2 3 and 4. The second largest index is becomes n minus 2th index. This is always become largest. Okay, this is always largest because this index is n minus 1, and sometime the second largest element is present at n minus 2th index, or sometimes it is present here or not. Okay, by this way we are starting our loop from I is equal to n minus 2, because we have to traverse this array from this side. Sometime our second largest element present is present at here, and sometime not. Okay, so this is the code for brute force approach, and the time complexity is big O of. In sorting, the time complexity becomes n log n. By iterating any loop, we have time complexity becomes big O of n, and here we have to add up these two time complexities to get final time complexity, big O of n plus big O of n log n. So the time complexity is n plus n log n. So this is the final time complexity for this particular question, this particular brute force approach, and the space complexity becomes big O of 1, because we are not using any extra space to store any element. Now we have to move on better approach, because because the time complexity becomes big O of n plus n log n. So this is not the best time complexity, so we have to optimize our solution. So ARR is equal to 1 2 4 7 7 5, and here if we have to find the largest element now. In previous video I provide the the optimal approach for finding the largest element. Okay, so how we find the largest element by optimal approach? The time complexity becomes big O of n, so we have to find the largest element now. So largest element, we have firstly we have stored ARR of 0. We suppose the largest element is ARR of 0. Okay, then we have to traverse each elements int I is equal to 0 to finding our largest. Okay, if ARR of I, if current element is greater than largest, so you are become my largest. Okay, so ARR of I is our largest because it is greater than largest. Okay, so this is the code for our largest to find our largest element, and here time complexity becomes big O of n, because we are traversing our array by a single iteration. Okay, now we have find we are already find what is the largest element. Largest element is 7. The largest element is 7. By traversing each element, we get largest element is equal to 7. And then we have to find the second largest element, no? So second largest element, we suppose there is no negative numbers, so we suppose our second largest element is -1. Okay, and we have to traverse each elements by I is equal to 0. Okay, I is equal to 0. We have to find second largest element, and we already stored -1 because there is no negative in this array. We have starting iterating from I is equal to 0. Hey, are you greater than second largest? He said yes, I am greater than second largest because 1 is always greater than -1, na? So I am greater than second largest. At same time, are you not equal to largest, na? 7 is not equal to 1. Okay, I am not equal to largest. So store 1. Okay, store 1 and traverse on another element. I is equal to 1. Again compare. Hey, are you greater than second largest? 2 is greater than 1. So I am greater than second largest. Okay. Are you greater than second largest? It is fine. At same time, are you not equal to largest, na? Are you not equal to largest? He said yes, I am not equal to largest. I am 2 and largest is 7. So I am not equal to largest. Okay. So update second largest. Update second largest. Because I am greater than second largest. And I plus plus. I is equal to 2. Here element is 4. So compare with second largest. Hey, are you greater than second largest? He said yes. 4 is always greater than 2. So I am greater than second largest. So also compare. Hey, are you also not equal to largest, na? Are you not equal to largest? He said yes. 7 is not equal to 4. Okay, so update second largest to 4 and update yourself to I is equal to 3. I is equal to 3. Here element is 7. Let's compare this element with the second largest. Hey, are you greater than second largest? He said yes, I am greater than second largest. 7 is always greater than second largest. The element is 4. So I am greater than so 7 always greater than 4. Okay, and we have also compare at same time. Is 7 is greater than is not equal to largest? He said no, I am equal to largest. I am not equal to largest. Okay, 7 is equal to 7. Here element is 7 and our largest element is also 7. So they both are equal. He said no, I am here I am equal to largest. So don't update yourself. Let's move on. So I is equal to 4. Here also element is 7. Let's again compare. Hey, are you greater than second largest? He said yes, I am greater than second largest. 7 is always greater than 4, na? So I am greater than second largest. At same time, you are not equal to largest, na? He said no, I am equal to largest. So update yourself. I is equal to 5. Here element is 5. Hey, are you greater than second largest? He said yes, 5 is always greater than 4, na? So at same time, you are not equivalent to largest. He said yes, I am not equivalent to largest. 5 is not equal to largest. Okay, so update second largest to 5. So I am writing the pseudo code for this. This is the better approach to deal this question. we have to iterate this elements by one. So simply for loop from I is equal to 0 to n, and here if ARR of I is greater than second largest, okay, at same time it is not equivalent to largest, okay. So update yourself to ARR of I, okay. And the second largest element is starts with uh, second largest is equal to -1, because there is no negative in this array. So this is the better approach for this particular question or problem. If you are not understanding well, so please rewind this video and again watch this video, okay, because this concept is something important. You don't miss this concept. I again repeat this concept. We have a declare second largest element and largest element. The largest element we have a find by iterating the array and compare if are you greater than largest, so update largest, okay. Here largest is ARR of I. After iterating the loop, iterating the array, sorry, we get our largest element, and then we have start our second largest element by supposing that our first element is -1, because there is no negative in this array, okay. And then we compare by iterating each element in this particular array. Hey, are you greater than second largest? He said yes, I am greater than second largest. One is always greater than -1 na, so I am greater than second largest. So it is always at same time you compare with second largest and largest. Hey, are you not equal to largest? He said yes, I am not equal to largest. So update yourself. So second largest becomes second largest becomes 1, and then further we compare this element with second largest. Hey, are you greater than second largest? He said yes, I am greater than second largest. At same time you are not equivalent to second are you at same time you are not equivalent to largest na? He said yes, I am not equivalent to largest. So update second largest. So by the iterating these elements by again and again, we get our second largest element, and finally if we have to return this second largest element, so we have to return this second largest element, and then this is the code for this particular better approach. And what is the time complexity? Time complexity becomes here for finding largest element is big O of n, and by iterating each elements to find our second largest element is also big O of n. Here also the time complexity becomes big O of n. So the time complexity becomes big O of n plus big O of n, which is big O of 2n, okay. So the space complexity becomes big O of 1 because we are not using any extra space to store our elements. So this is the better approach for this particular question or problem. Now we are moving to optimal approach for this particular problem. So let's move. So now we are here to find out what is the optimal approach for this particular problem. So firstly we have declare the largest element. We are supposing that largest element is ARR of 0, okay, and the second largest is -1 because there is no negative in this particular array. Okay, if any negative element is also present, so you use int minimum. Okay, int min. So we are going to iterate in this particular array, because in better approach we have the time complexity is big O of 2n, so we have to optimize this time complexity now, because space complexity is big O of 1. We have to not optimize this space complexity, the time complexity is optimized further. Okay, here the time complexity is big O of n, because we are using only one loop for iterating each element. Firstly, we are here I is equal to 0, I is equal to 0, and we are iterating in this particular array. Here 1. Hey, are you greater than largest? He said 1 said 1 is not greater than 1. Okay, so we have to take another element I is equal to 1. Okay, we have to iterate from I is equal to 1, because this is already taken by largest element. Here we have to compare. Hey, are you greater than largest? He said yes. Here the value is 1 and here the value is 2, so update the largest. Now largest element is 2. At same time, if largest element is 2, okay, so the second largest becomes 1 na, second largest becomes 1. If here we suppose the largest element is this span, by height wise the height of this span is let's assume this span height is 1 meter. Okay, on same time one another pan comes, or say my height is 1.5 meter. Before entering this span, the largest element is this. Okay, after entering this span, the second largest element becomes this span. Okay, I hope you understand well. The largest element firstly is this, because there is no competitor in it. After entering this is the largest as compared to this, so this becomes second largest now. So this is our second largest and this is our largest. By this we say that the second largest the first largest becomes 2, and the value of largest is stored in second largest. Okay, now we have to move our I is equal to 2, and then here compare. Hey, are you greater than largest? He said yes, I am greater than largest, so update the largest. But before updating largest, we have to store the value of largest into second largest, which is 2. Okay, and then we have to move our I. Here I is equal to 3, here I is equal to 2. I is equal to 3, the element is 7. Let's compare. Hey, are you greater than largest? He said yes, I am greater than largest. But at same time you are at same time you give your value to second largest, so update the second largest to 4, and then store 7. Okay, and move your I is equal to 4. Here the value is 7. Let's again compare. Is largest is greater than the current element? He said the current element value is not greater than the largest. So move the I. and then I is equal to 5. Here I is equal to 5 and the element is 5. Okay, so what is the if the current element is greater than largest, is are you greater than largest, is 5 is greater than largest? He said no, I'm not greater than largest. But 5 is 5 to be stored in second largest na, because 5 is the second largest element in this particular array. Okay, so we have to store this 5 to this second largest, so update the second largest, so the second largest element becomes 5. Okay, so I'm writing the pseudo code. Okay, largest is ARR of 0, second largest is starting from -1, and then we have to start our for loop. Int I is equal to 0, I is equal to 1, because we are iterating from I is equal to 1, not from I is equal to 0. Okay, I is equal to 1, I is lesser than and equal to n, and always I plus plus. We have to compare if ARR of I is current element is greater than largest, so store the value of second largest, so store the value of largest into second largest, so the value of largest becomes is stored into second largest, and update the largest value to ARR of I. Okay, else if ARR of I is lesser than largest, if our current element, now we are talking about 5, what if the largest element, what if the second largest element is 5. Okay, so we have a else if condition. If current element is lesser than largest, okay, at same time and ARR of I is greater than second largest. Okay, so update second largest to ARR of I, because this element is lesser than largest, and this element is greater than second largest, so update the value of second largest, and then here if you have to return second largest, so return second largest. Okay, here time complexity is big O of n, because we are iterating by a single loop, and space complexity becomes big O of 1, because again we are not using any extra space to store our array elements. By this we are completing our optimal approach for this particular question. I hope you understand this particular question into very deep. If you practice this particular question by one or two times, so you definitely solve this particular question by your end also. Thank you everyone for listening me carefully. If you are new to this channel, so please subscribe this channel, and bye.